Hi. So, welcome to our next lecture on cloud computing. We will quickly go through the virtualization concept. We have already discussed some of these aspects in our previous lectures, but I thought that we will have some few more slides on it, one of the core concepts. So, virtualization is one of the core concept or one of the core prime mover of having this cloud computing, which for which the cloud computing is existing today. And if you see, this virtualization is not a new concept, it is already there. Many of us are used to virtualize. We virtualize say a Linux system over a Windows system over a Linux system. So, I have some sort of a virtual realization of the things, right. And if you look at that other end, we are used to leverage other resources like networking, etc. So, we can have a virtual LAN or VLANs, which is pretty popular, which we have VPN, virtual private networks, and so on and so forth. So, virtualization is there, and this cloud computing architecture technology tries to exploit this feature for giving different services of cloud. So, as we have seen this IaaS or infrastructure as a service. So, from the subscriber point of view, what the subscriber gets? So, access to virtual computers, right, network accessible virtual storage, network infrastructure components like firewall, configuration services, etc. So, as if I being a subscriber, I get a access to a virtual machine, right, or set of machines, and then I may want that particular machine with particular storage and other configurations. So, I do not know where it is, how it is configured, but for me, if through this particular that interface, it is a particular it is a type of machines which I am looking for. Even it is possible that I have a combination of these virtual machines along with a particular backbone network and realize a network infrastructure for my purpose, right. So, this is that what subscriber gets from me, and how uses and what subscriber pay for it is basically typically per CPU hour, GB data stored maybe on a hourly basis, network bandwidth consumed on a particular rate, network infrastructure used, that how much IP address, which are the routers, etc. And value added, there can be value added services like monitoring, automatic scaling and type of things, other things which are value added services. So, providers theoretically have a large pool of virtual machines. That means, if I am a cloud service provider, I say that these are my flavors of virtual machines which I am having at my thing, right. And then I say that if you want a set of virtual machine, then I go on provisioning it, right. And usually these are into different categories, though theoretically I can configure any of the virtual machine, but in practical sense it is under with specific configuration and etc. Like I say that I have VM with very low things, like in case of our Megamala IIT Kharagpur, we have a virtual three type of virtual machines. One is IIT KGP small VMs, which has a 4 GB RAM with 20 GB hard disk space, and these are the other processing, etc. We have a IIT KGP large, which has a 8 GB RAM and so on and so forth, which have a we have a IIT KGP extra large, which has a 16 GB RAM. Say these are the three flavor. Now, based on that, based on my backbone resource availability, I have a mix and match of the things. Not only that, the type of VMs I will have is also dependent on type of request I get on these VMs, right. If I have a heavy request on only the smaller type of VMs, then I want to provision the smaller type of VM much more than the higher things, and so on and so forth. So, these are the considerations which come into play, right. So, like in this case, A has a access to VM1 to VM2, right, whereas B has a access to VM3, where the client C has access to VM4 to VM6, where the providers retains VM7 through VMN for his other users. So, that can be a model and go on doing that, and these are typically done like that. So, if we look at the IaaS component stack and scope of control, IaaS component stack comprises of hardware, operating system, middleware and applications layer. So, these are the typical thing. So, operating system is built into two layers, lower the most privileged layer. So, if we look at the more code to the operating system is occupied by the virtual machine monitor or VMM, which is also called the hypervisor, right. Higher layer is occupied by the operating system running within the VM called a guest operating system. So, as we have seen that we have a, like in this case in the middle, if you see, that is I have the bare metal hardware where the cloud provider have a total control, cloud subscriber has practically no control. Over that we have a hypervisor, right, or VMM or virtual machine monitor, where the administrative control of the cloud provider or cloud subscriber can basically request for VM etc. to this hypervisor. And then we have other layers like guest OS, middleware like Java etc., application like mail and CRM and other type of things, where the subscriber has the total control in case of a IaaS, where the provider does not have any control or provider does not control it for the thing, right. So, this is the way it goes on. So, if we look at it, the type of control at the upper layers are more to the subscriber and type of controls at the lower layers are more to the providers. So, in IaaS cloud provider maintains total control over the physical hardware and administrative control over the hypervisor layer. Subscriber control the guest OS, middleware and the application layers, which are the subscriber. Subscriber is free using provider utility to load any support operating system, I think. So, if the provider provides the support, the subscriber can load any guest OS. Subscriber typically maintains complete control over the operation of the guest operating system in each VM. So, though the subscriber once it loads, it has the total control over the guest OS. Like if the cloud provider is providing me some Linux OS and a hypervisor and allows me to load Linux or Windows etc. So, if I load some flavor of Linux, then I have a total control over that particular thing. IaaS component stack and other things, the hypervisor uses hardware to synthesize one or more virtual machines or VMs, is an efficient isolated duplicate real machine. Subscriber rents access to VM, the VM appears to be subscriber as actual computer hardware that can be administered, that is powered on off, peripheral configured via commands sent over the network etc. So, that it because what I am having as a subscriber is primarily interface with the provider and I can go on communicating with that. So, typically if you look at a typical architecture, so there are several components. At the top is the cloud manager, there are different cluster managers which are at the second level of the things, and below that is the computer manager or CMs, right. And the CM is basically has these hypervisors and different type of virtual machine emulated over the things, right. So, we have at the cloud manager end the data object storage, which is the master database of keeping track of the things. Then at the lower level we have a persistent local storage, right. So, that means the storage which does not go away when the cloud provider is not there, when the VMs are not used or shut down and type of things. So, if we look at the 3 level hierarchy of the components of IaaS, one is the top level is responsible for the central control like the cloud manager, the middle level is responsible for management of possibly large computer cluster and maybe geographically distance from one another. So, if you look at this cluster manager, it is managing these large clusters which may be geographically spread, and the third is the bottom is responsible for running the host computing system on which virtual machines are created. So, these are running this host computing system where the VMs are created, right. So, this is typically 3 layer of control. Subscriber queries and command generally flow into the system at the top, are forwarded down through the layers which either answer queries or execute commands. So, IaaS cloud architecture, cloud manager can be geographically distributed. Within a cluster manager, computer manager is connected by a high speed network. So, this is this if we look at the cluster manager, these are all connected to a high speed network. So, now if we look at the quickly that operation of the different things. So, what we have, cloud manager at the top, then the cluster manager, then the computer manager, which manages the individual things, right. So, if you look at the cloud manager duty, is the public access point of the cloud, that is the first thing. So, whenever somebody is accessing the cloud is the public, where the subscribers sign in for accounts, manage and resources they rent from the cloud, etc. Cloud manager has the mechanism of authenticating the subscriber, whether the authentication mechanisms, generating or validating access credential with the subscriber when the communication with the VMs, like when it is basically the front end of the whole system. Top level resource management. So, for subscriber request, cloud manager determines if the cloud has enough free resource or to satisfy the things. So, subscriber resource on the things. So, cloud manager maintains a metadata information. So, if I request for a particular VM or a set of VMs which are not available on the cloud, then it becomes a the cloud manager has to take a call. So, it manages at the subscriber level. There is a thing called data object storage or DOS. DOS generally store the subscriber metadata, as we are talking about the user credential, operating system, etc. DOS devices usually single for a cloud. So, what we say that the particular DOS service is for a particular cloud. So, it maintains a what we say registry or a cataloging or a metadata service for that whole cloud. So, it is the binding block of the whole thing, that what are the services available, whether the free resources available, etc. are all updated in the DOS. So, if you look at the cluster manager, that is the middle level. So, it is responsible for operation of collection of computers that are connected by high speed local area network, right. So, that is it manages the lower level computers. Cluster manager receives resource allocation commands and query from the cloud manager at the top and calculates whether the part or all of a command can be satisfied using the resource of computers in the cluster. That means, when the cluster manager gets a request, it checks that whether its available resource within the cluster, whether it is able to satisfy the things, and accordingly it says a appropriate signal to the things, like whether it can accept or cannot accept and type of things. Cluster manager queries the computer managers for the computers in the cluster to determine resource availability, returns message to the cloud manager. That means, it becomes a middleware or a agent between the cluster manager and the cloud manager. If we look at the operation, it get the direction from the cloud manager and then instructs the computer managers to perform resource allocation, reconfiguration, deallocation of resources, and etc., etc. Each cluster manager is connected to a persistent local storage. That means, that it is the so called quote unquote non-volatile storage, when the particular virtual machine is shut down, deprovisioned, or some issues come up, so that it has a local storage into the things. So, this PLS provide persistent disk like storage to the virtual machine. Okay. So, it is as if persistent disk like machine things are there. So, the data when you next time log in, it will be available with you. So, if we look at the operation of the cloud manager, at the lowest level in the hierarchy, cloud manager runs on each computer system, uses concept of virtualization to provide virtual machine to the subscriber. So, cloud manager is basically providing the VMs. So, it is to the subscriber this providing VMs, it is responsible for that. Computer manager maintains status information, including how many virtual machines are running, etc., etc. So, it maintains the status information as of now, how many virtual machines are running. Also, cloud manager uses command interface to hypervisor to start, stop, suspend, reconfigure virtual machine. So, it also send the if there is a need to the computer manager. So, all this what we see is virtualization plays an important role, right. So, how this virtualization is made and what are the aspects etc. thing we will try to see quickly in the subsequent slides. So, virtualization is a broad term, it can be virtual memory, it can be virtual network, it can be virtual storage etc. So, anything which can be virtualized is a virtualization aspect. So, our primary focus is the platform virtualization, right. Virtualization basically allows one computer to do the job of multiple computers, right, by sharing resources of a single hardware across multiple environment. So, that is important. So, that means, I have a bare metal, then I create different machines or virtual machines which can cater to the things, but at the back end my same bare metal is running. Now, this becomes a very tricky issue, because suppose you are running, if you are having your bare metal on particular environment, and then you are running one machine on Windows, one machine guest OS on Linux, one machine on some other things etc., then there is a problem of issue of how this say instruction set of this guest OS will be running on the hardware at the end. So, that there are issues of like that, there are issues of application sizing, there are issues when the VM says that I require more resources or I want to release other things, how it can be managed and so on and so forth. So, if we look at the hardware, so if it is a no virtualized system, a single OS controls the all hardware platform resources. If it is a virtualization system, it takes the possibly it makes it possible to run multiple virtual containers on a single physical platform. So, I can have multiple virtual containers which can run on or which can be plugged into a single physical infrastructure. So, we are somewhat experienced with this virtualization. So, virtualization is a way to run multiple operating system and user application on the same hardware. So, that is virtualized. So, I can have two different operating system on the same virtualized. That means, I say I virtualized one this OS out of this, right. So, run both Windows Linux on the laptop. So, how it is different for dual boot? Dual boot also we are doing that once Windows etc. Here in case of virtualization, this different OS or all the OSs are running together, right, or simultaneously. The OSs are completely isolated from each other, right. They are completely isolated from each other in case of a true virtualization. Now, another important aspect of things which come into play is the virtual machine monitor or hypervisor. So, a hypervisor or a virtual machine monitor runs the guest OS directly on the CPU, right. So, that means, I have a guest OS and at the as my which has been emulated or installed by the subscriber or running on or its application on the of the client, and then the hypervisor is responsible to execute this or run this guest OS directly on the hardware at the back end of things. So, this works if the guest OS uses the same instruction set of the host OS, right. If it is a different instruction set, then there is a instruction translation should come into play, right. So, there are several issues as depicted by Pocek and Goldberg, that three goals of virtual machine architecture are there. One is that equivalence, the VM should be indistinguishable from the underlying hardware. So, as if the virtual machine is running on the hardware itself. So, what we say it is equivalence, or resource control, the VM should be in complete control of the virtualized resource. So, if you give me 4 GB machine, 30 GB, 60 GB hard disk and so forth, that I should have a complete control over the thing, right, as a subscriber. And efficiency, most VM instructions should be executed directly on the underlying CPU without involving the hypervisor. So, that is another thing. So, efficiency will increase if the most of the virtual machine instruction should able to execute directly on the underlying CPU without intervention of this other involvement in the hypervisor. So, these are the aspects which need to be looked into when we have virtual machine monitor or hypervisor in place, which allows me to emulate VMs. So, again in the same work, this Pocek and Goldberg describe and also provided a formal proof of the requirement of the CPU's instruction set to allow these properties to happen, like to allow truly virtualization happen at the highest level. The main idea is classifying the instruction into three different things. One is privileged instruction, which cause a trap in the executed in the user mode. There is a sensitive instruction which change the underlying resources, that is doing IO or changing the fact that the guest OS is running on the bare metal, etc. Means first of all changing the IO or the page tables, or observe the information indication of the content privilege level. So, if you remember your operating if your basic architecture things, so I have different level of operations like level 0, level 1 and so forth. So, more the lower the levels, I go more closer to the bare metal. So, it all depends that your virtualization at which point it operates. More the higher level, then more latency will come into play, more translation will come into play. So, we need to look into the things that what level of operations I need to do, especially when we do IAS type of operations. And the former class of sensitive instruction also called control sensitive, or later called are behavior sensitive operations, right. So, what this Poke and Goldmark show that if we can run a virtual machine with all the three desired property, if the sensitive instruction are a subset of a privileged instruction. In their work they have shown that this sort of things are true, and we can realize a true virtual machine. So, the same thing or the whatever we are discussing. So, we have these VMs and this hardware over this virtual machine monitors is running, and it allows us to emulate these different VMs, right. So, it can be your so somewhere or other this whatever the guest OS running on the VM, the instruction set need to be converted, which can be understood by this hardware, right. So, that is our bottom line. So, whether the whole VMM will have a total abstraction or also have some sort of overlapping with the things, that depends on what is the implementation. So, if we look at the approaches, typical approaches to virtualization. So, if you see the evolution of this virtualization, one is what we say first generation or full virtualization. So, binary rewriting. So, it is software based, VMware and Microsoft supports this. So, whatever the virtual machines are generating, a dynamic translator rewrites to the underlying hardware and so forth. In case of a second generation virtualization or para virtualization, cooperative virtualization. So, it is a cooperative virtualization, the guest OS or the is modified and VMware Zen does it. So, it basically if you look at here, so it penetrates little bit onto the VM, that means that is modified on the things. In case of a third generation or what we say silicon based, that is hardware assisted virtualization, unmodified guest VMware and Zen on the virtual aware on the virtualization aware hardware platform. So, now your hardware platform is a virtualization aware. So, it is hardware assisted virtualization. So, in these cases these hardware platforms are not aware of this virtualization, whatever is done by this your hypervisor. So, there are different things in case of full virtualization, first generation offering. So, dynamic binary translation of the source code, as we have seen, all the hardware is emulated including the CPU to popular open source emulator. Many of you might have seen QEMU and BOSS, these are the two popular emulator which change that open source. Full virtualization, there are advantages of emulation layer, like you do not bother about that, two things are separated. Total VM portability, like I can take the VM from one to another. So, total portability, because only the VMM I need to understand those. There are drawbacks, this hardware emulations comes with a performance spice. Whenever you want to emulate a hardware etc. performance spice, in traditional x86 architecture wake kernel expect to run on the privilege ring 0, and now you want to run them at a higher level, and that need to be, there should be more latency and other things come into play. So, you need to pay for that, or what you need to, there is a performance price for that things. In case of para-virtualization, guest OS is modified and thus run kernel level operating system at ring 1 or ring 3, that is much higher level. Guest is fully aware of how to process privileged instruction. Privileged instruction translated to VMAs is no longer necessary. Guest operating systems uses specialized API to talk to the VMA, right. So, it is para, that means your VMAs is penetrating to you some sort of into the your VMs. So, that now it is not full translation, but I have a para virtualization, the performance increases and these things is becoming pretty popular. So, in case of a para virtualization, recompiling of the OS kernel is required because that is penetrating into the things. Installing of para virtualized drivers are required, so that it takes care at your guest OS level. The third one is a hardware or OS running on a ring 0. VMM uses processor extensions like in case of Intel, VT or AMD V and type of things to interpret the privileged things. Hardware assisted virtualization removes many problems that take place in writing a VM into writing a VM into rather it is a big challenge. So, that it is hardware assisted. So, that means you go directly, your thing is totally fully compiled. In doing so, you lose that portability of the VMs, right. It becomes a more tricky issue because you need to migrate to some things which understand that hardware. Pros, it allows run unmodified OS, right. The OSs need to not be modified. Cons is the speed and flexibility is issues, that that your flexibility you lose and the speed, it depends when the migration etc. comes into play. So, with that we will just touch upon some of the one more aspects of the things what we say network level virtualization. So, that now what we are talking as the hardware, now we are looking at that network level. That means, I need to emulate a network over a virtual network over a given network, right. So, typical approaches what we have seen is that in case of a network technology, that is whether IP based or ATM based, layer, which layer of virtualization is there. There are architectural domain, the network resource management, spawning network and type of things, level of virtualization, whether it is node level or full virtualization of the things. Like if you look at, suppose I have a network like this, then I can emulate a virtual network like this, or I can emulate a virtualized network like this, right. So, this is my base network. So, I can have two type of virtual network under this over and above of those things. So, I emulate a virtual network. Why to virtualize? Now, what people say that not only internet, in your own networking paradigm is becoming paralyzed, like you do not have much elbow space, hard to come with a one size fit all type of architecture in number of cases, like you have a network configuration and fits everybody. So, why not to create something that all sizes fit to one in-state type of scenario. So, that is the things what we want to do. So, test base for future, and that is and any futuristic working on the network protocols and etc., we require a test base. For that, putting a whole networking things may be a challenge. So, I can have a sort of a virtualized network, and this is not suddenly came into play. We have lot of things which are already in play, that is a virtual private network, active and programmable networks, overlay networks, these are already in place for several years, and this is being emulated over that. And if we look at, there are different type of aspect like business model, architecture, design principle, design goals, and those are the things, and there are different aspects of those like infrastructure providers, service providers, end user, brokers, these are the different players, and they have a very complex relationship between each other, that how things will be there. And these business models is not only true for network virtualization, it is true for other sort of virtualization as well. And if we look at that architecture, so if I have that infrastructure provider, then I have a service provider 1 which is have some sort of a virtual network emulated from this, like making active some of the networks etc. And I can have other type of service provider 2 SP2 emulating other type of networks as well. So, I can emulate different variety of network on a basic underlying network. So, I can realize different networks into the things. So, these are also becoming very popular. So, having say not only having servers, like I want to conduct a particular testing over across the across a large logic geographical space. So, not only I want these servers into the place, I also have a particular network infrastructure into play, right. Then those then if we want to do have those type of things, then I not only require the virtualization at the IaaS level or the server level virtualization, I also require a network level virtualization into play, and making this overall I can have a virtualized IP infrastructure into place, right. So, we will continue our discussion in our subsequent lectures. We will stop here today. Thank you.